Hello physics students, and welcome to our next unit that deals with motion. This unit will be all about force, and we're going to start with section 3.1 and talk about what is force. We're going to look at units of forces, difference between contact forces and field forces, and we're going to take a look at force diagrams. So first, what is a force? You've probably learned in middle school force is a push or a pull. Force represents the interaction of an object with its environment, and force essentially can cause a change in motion, can cause objects to start moving, stop moving, or change in direction. The units of forces are important to keep track of. The SI unit of force is the Newton. 1 Newton is the same thing as 1 kilogram meter per second squared. That is what a Newton is. The unit of force can be measured differently in different units or in different systems. The SI system is the one that we'll be using. We measure mass in kilograms, obviously, and acceleration is measured in meters per second squared. And therefore, the force is going to be kilogram meter per second squared, or a Newton. These are just some FYI. Different systems use different units for force. These are kind of interesting. You could look into, why do we call pounds LB? Why do we abbreviate those LB? Look into that if you're interested in some advanced proficiency. These are kind of interesting. Anyway, roughly 4.448 newtons is about a pound equivalent, and as you all know, weight is a unit of force. So when we talk about pounds, we are not talking about a person's mass. It is not an inherent property of an object like mass is. Mass is the amount of matter in an object. Weight is the amount of force that an object is experiencing. So it's important to note that forces can act either through contact or at a distance. Contact forces are very easy to recognize because those are forces that result from physical contact between two objects. We have here examples of physical contact, and the pushes or the pulls are a result of physical contact between the objects. Another type of force would be field force. Field forces can exist between objects even when there is not physical contact between them. Some really good examples of field forces would be the attraction or repulsion between electrical charges. This is demonstrated right here, or the attraction or repulsion between magnetic objects here. You also have the force of gravity that is acting at a distance. We have the forces between these two objects that are attracting one another, gravity, the gravitational force, and that is a field force as well. So let's take a look at how we can represent forces in a diagram. We call those force diagrams, where we represent all the forces acting in a particular situation. The force vectors are shown as arrows. Here we have a force diagram showing the force vectors as arrows, and regardless of where on an object the force is applied, typically in force diagrams, the forces are drawn as though they act on the center point of that object. So we simply draw from the center the different forces that are acting on that object, and you can see this is the force that is exerted by the wall on the truck. This is the force that is exerted by the truck on the wall. Here's the force of gravity and the force of gravity coming from the center point of each of those objects. And then this would be the force of the road and the force of the road, or whatever this is right here, the ground, acting in the upward direction. So in a force diagram, the vector arrows represent all the forces acting in a particular situation on whatever objects are involved. Something called a free body diagram is a diagram that shows only the forces acting on a particular object of interest. So in this case, here's a free body diagram of the little truck from our last force diagram. The free body diagram simply takes the object of interest and shows the forces acting on that object of interest. Now we're going to practice drawing a free body diagram. It's important to be able to sketch quick free body diagrams in physics so that you can think about different problems and different situations. It's also important to note that you do not need to be an artist. So in this case, I did draw a little shape outline of this car, but you could certainly draw just simply a rectangle, put a little circle on there for wheels. You do not need to be artistic, but simple shapes work best. So simple rectangles and circles are nice. So for this free body diagram, after we draw the simple shape of our object, we're next going to look at some of the different forces at work. One of the obvious ones to everyone, it would be the force of gravity. So if we draw that arrow first, representing the force of gravity, there is our first force vector in our free body diagram. That force of gravity in this situation happens to be 14,700 newtons, so we can write the amount of force that is being exerted by gravity on this car in our diagram as well. The next vector that would probably be nice to draw, if we know the force of gravity is acting down, we also know there is a force in an upward direction exerted by the road, where the tires are resting right here. So let's draw that vector. And that one is represented facing up from the center of the car at a force of 13,690 newtons. When the tow truck is pulling this car and moving it forward, we have a force that is exerted in this direction by the tow truck of 5,800 newtons. We also have force exerted in this direction, again, the force of friction from the road that is in the opposite direction of the direction that the car is moving. And that is represented here. I could not draw my arrow any shorter, but 775 newtons. So you can use the free body diagram, any free body diagram that you draw, to find out what the net external force acting on any object would be. You can use your rules for vector analysis that we learned in our last unit, and you can determine what the net external force acting on that object is. So to sum up what we just learned, you know what force is, you know what the SI unit of force is, you know the difference between contact forces and field forces and some examples, you know what a force diagram is, and you know what a free body diagram is and how to draw one, and that it can be a useful tool in determining the net external force acting on an object. If you want some more advanced ideas, how about this? Try looking at some occupations that require an understanding of forces. Look at some areas that might be of interest to you, and look at the salary, the work hours, the work environment for some of those different occupations, and come and tell me about it. So I look forward to seeing you in class.